Hey everyone, and welcome to NoelsMarine. Today, we're going to go deep, right down into the naval architecture basics of a large ocean-going vessel, to explore Introduction to Naval Architecture Basics. Here's what we're looking at today. We'll kick things off with the absolute basics of naval architecture. Then we'll dive straight into buoyancy and displacement. After that, we'll cover ship draft, get into freeboard concepts, and finally, wrap the whole shebang up with reserve buoyancy. Let's jump right in.
Section 1. Naval Architecture Basics.
So first things first, what exactly is naval architecture? You hear the term and it sounds super intimidating, right? But honestly, it all boils down to just a few key interconnected areas. At its core, it's the science and, let's be real, the art behind designing and constructing ships, along with pretty much any other marine structure out there. It's like a giant puzzle. A naval architect is constantly juggling things like stability, resistance, propulsion, and structural design. They have to nail that perfect balance to make sure a massive vessel can handle literally whatever the open ocean decides to throw at it.
Section 2. Buoyancy and displacement.
Okay, so to truly grasp how these absolute behemoths stay afloat, we first need to define buoyancy.
Simply put, it's the upward force exerted by the water. It pushes up and directly opposes the massive weight of the ship pushing down. It's an absolutely incredible balancing act.
And that brings us to our next major concept, displacement. Honestly, it's exactly what it sounds like.
So, what does this actually mean? Displacement, which we represent with the delta symbol, is determined by taking the water's density, rho, and multiplying it by g, the acceleration due to gravity. To put that into plain English, a ship's displacement equals its total underwater volume, and that has to account for the ship's actual weight plus every single thing it's carrying, like dead weight, fuel, and stores.
Moving on to Section 3, Understanding Ship Draft.
Now, you might be wondering, what exactly does draft mean in the shipping world? How does a ship actually sit in the water?
Draft is essentially just the vertical distance from the waterline straight down to the very bottom of the hull. Now, if the draft at the back, the aft, is deeper than the forward draft, we say the ship is trimmed by the stern. On the flip side, if the front is sitting lower, it's trimmed by the head. Actually, scratch that. You almost never want that. Being trimmed by the head is usually highly undesirable because it totally messes with the vessel's stability and steering.
Section 4. Freeboard concepts. So, what is freeboard, and why is it absolutely crucial for keeping a vessel safe?
Freeboard is the distance from the waterline all the way up to the main deck. It's basically your ultimate safety margin against heavy flooding. The rule of thumb here is simple. The greater your freeboard, the greater your reserve buoyancy. And more reserve buoyancy means a much safer ship when those seas start getting rough. And finally, Section 5. Reserve buoyancy.
We just mentioned it, but let's define it. What exactly is reserve buoyancy?
Think of reserve buoyancy as the completely watertight volume of the ship that sits above the waterline. It's literally a built-in safety buffer. If the ship takes on damage and starts to sink, this extra volume gets pushed underwater, adding to the total displacement volume and fighting to keep the vessel afloat in an emergency. It's a real lifesaver.
If you found this breakdown useful, give the video a like, share it with your fellow engineers and maritime cadets, and subscribe to NoelsMarine for more detailed deep dives into the Introduction to Naval Architecture Basics. Hit the bell icon so you never miss an upload, and we'll see you in the next one.